Hi folks, welcome to The Breaking. My name's Henry, and today we're going to put the USB to CoCo keyboard adapter onto a printed circuit board. Now, it did come up in a conversation about the first video in this project series that we might be able to use this with other machines. The upshot is that the design is going to be flexible enough that any machine that speaks key switch matrix will be able to make use of it with some caveats. The first is that the code will have to be changed, obviously. Not all that speak keyboard matrix speaks the same one, i.e. even CoCo and Dragon speak different. And we're limited to an 8x8 matrix. Now, that caveat goes away to an extent if we switch over to the MT8816, which will give us an 8x16 matrix, which is enough for an MSX computer. Now, I don't have an MSX computer to test on, but, you know, somebody wants to send me one? Hey, I'm not going to say no. I'll test on it. For now, though, we'll stick with the MT8808, and we'll enhance the matrixing capabilities later. Anyway, let's get going with this stage of the project right here on the break key. There will be solder fumes. First of all, obviously we've got the Pi Pico, and then don't even have to worry about that. We've got the MT8808, and then we've got these bad boys right here, which, believe it or not, those are just some in-channel MOSFETs that are being used on that. Instead of using these that plug into the breadboard, we'll just go ahead and replace those with the discrete components. And if I go and look up that discrete component, I should be able to find it. So yeah, this is nothing but a BSS 138 with a couple of 10K resistors on it, low voltage to high voltage and everything like that. So that's going to be real easy to just go ahead and pop into place. I'll just need a few of those. So, you know what? I'll go ahead and start with that, with the BSS 138s. There we go. That's exactly what I wanted to see. Okay, so now for the level shifters, we'll just go ahead and get those. What are those BSS what? Yeah, those are BSS 138s. And I've got those in there. I can get the Pico in, and let's see if we've even got a Pi Pico. I don't see anything like that. And we've got this right over here, the KiCad RP Pico libraries for the, yep. I'm just going to need to grab those. So now I need to get the MT8808 in here, and I don't know if that exists. Let's see. I don't see anything. I did a search earlier. I don't think it exists, so we're going to have to add the symbol in. So we're going to go to the symbol editor. Looks like everything's good and connected. So I should be able to save that. And then comes the next part. Let's go to our PCB editor. to do my fab outputs. I want so now with all that done, I need to figure out how this is going to work for a BOM. All right, that looks good. That actually looks pretty darn good. That makes me happy. Now for the rest of it, I think I've got a problem with it being because UTF-8 versus UTF-16. Okay, now it makes sense. Good. All right, we're good with that. Okay, because it's just too darn small. All right, so let's check this out for a second. The components themselves are cheap. Everything having to do with the assembly and packaging is cheap. What's expensive here is the setup fee. So I'm guessing that I may have to do the setup fee again later if I reorder this. But you know what? I'm not going to worry too much about it. At least not right now. Wait's going to be about that much. Assembly 2 to 3 days 0. And I'm not adding for faster assembly. That's just not going to happen. So I can call that done. Those will be on their way relatively, I don't know, within a few days, but for you all watching, it should be a bit shorter. Cool. Let's see if it works. So let's see what JLC PCB brought in. Must admit, I do like this. This is nice. Nope, those are the resistors. Gadzooks, those resistors are tiny. No wonder I had to pay so much. Oh my God, those are insanely small. Those are ridiculously tiny. Oh, okay. I see what they did there. That snaps off because I had to use the standard PCB. Is that? Yep. Off that comes, and off that comes. Nice. All right. So the first thing I noticed is that, I wonder if I can make this get any closer. Let's see if we can do that. Focus, focus. Nice. Okay. So looking at this, that's not what I was. Oh, yeah. Okay. So we've got, here we go. Let me turn this around. Okay. All these grounds are nice and connected, except right over here. That's connected to vsys. That should not be connected to vsys. If it's connected to vsys, we're going to have issues. vbus is connected appropriately, vsys is not. Did I just lose focus, or is this thing just that terrible? So we're going to have to cut that trace right over there. And the other thing that I forgot to do was I forgot to put bypass capacitors on the plus V lines of the opto isolator and the MT8088. So those are going to need to be fixed. Now, thankfully, fixing that one bad trace there, that should be relatively straightforward. All I've got to do is just cut the trace. I'm going to set that to continuity because that's all I want to check. All right, so if I stick this onto a ground pin, which this one right here is a ground pin, so that should work. And I go over here to, let's see, where's the ground? That's not going to be connected, I don't think. Nope, and that's not. And let's see, this one? Yep, that one's good. That's a ground. Now, this is where it was not connected to this ground, but it was connected to vsys. And that looks like it's nicely cut. All right, so that trace has been cut. We're good. And then the other thing we're going to need to do is set up where those are going to bodge into, where the capacitors are going to bodge into. So if I grab the breadboard and start looking at what pins that attaches to, let's see, where are we? Ah, here it is. Okay, so that goes across, what pins are those? All right, so that dot indicates pin 1. I don't know if you guys can see it there. So those are going to go across pins 5 and 8, it looks like. And then this goes, let's see, this one hooks onto pin, what are you? You are 15, no. Yes, 15, 16, 17, 18. Looks like pin 19, and I'll verify that. All right, so that is between 5 and 8, and that is on, let's see, pin 19. Yep, between 5 and 8 and pin 19. All right, so I can close this, and we can go back over here to the overhead. think that is the board populated. Good. Board is populated. All right, that's good for now. And I'm going to go ahead and get my mess cleaned up, and we will call it, we will come back to this soonish. All right, so now I've got the CoCo one opened up and ready to hook things up to. Let's see if I can pull this down a little bit so we can see what's going on with that. I'm trying to remember where the heck the test points are. I need test point 4 for ground, and I need test point 12 or 5 volts. So that's test point 12. That's my 5 volts. That's good. Oh, there's test point 4 right up here. Good. Found you. All right. Let's plug that in. This should not cause any problems. And let's see what the composite input says. So if everything's right, we should see something, and we should see it go correctly. And I'll start by hitting the, what's the at key, which we defined as being the brace next to the, or the open brace. So I hit that, and I get nothing. What happens when I hit A, which is the next one over? I get a slash. Let's try a B. Oh, that was an S. Try an A. Okay. So at gives me nothing. Oh, backspace gives me an L. Let me reboot real quick. So at gives me nothing. A gives me the slash. B gives me a 7. C gives me a space. D gives me a W. All right. So with all that said, let me see if I can't pull up. We'll do that with what we saw was when we hit A, at gave us nothing. When we hit A, we got the slash. When we hit B, we got the 7. C gave us a space. And if I recall correctly, D gave us a W. Yep, let me see that. Yep, D gave us a W. So let me try. It looks like things are hooked up a little bit backwards. I'll bet you nickel I got all this backwards. Because if I've done this the way that I thought that I was going to do it, the X's were supposed to be the rows. No, the X's are supposed to be the columns. The Y's are supposed to be the rows. Do I have that right? Or is it the other way around? No, the Y's were supposed to be the columns, and the X's were supposed to be the rows, from what I'm seeing here. All right. So this means that I have probably ridiculously jacked up the way things are going with this, but that's not necessarily a big problem. Because what I can do is, if this is the did things backwards that I think it is, I can fix this in software. Okay, all right. I just got really, really bad. Oh, there we go. That's much better. Okay, so that was all the problem that we had. And I plugged this in. And now it should be working. Let me check this. It's not getting anything. that I've got another issue that I need to deal with. So turn you on. Sign of life. We've got that. Let's see what we've got now. Let's look and see what's going on with... I want to look at this. Okay. So if I hit an H over here, that's giving me a bunch of G's. H is giving me a G, so what is I? I is giving me at. I think I did that on the wrong one. Okay. Yeah, that's what it looks like. It looks like I did it on the wrong one. I think I went in the right direction, but I went with the wrong one. Okay, so let's go ahead and fix that. I have at. Okay. All right. A, B, C, D, E, F, G. Okay. I'll call that a win. I will definitely call that a win. Because this is something that I can now demo. Even if it's not quite right, it's still something I can demo. So coming back to the fab, there are a few things that are missing. For instance, we're missing bypass capacitors, and these bypass capacitors are going from the power pin on the MT88 to ground and the power pin on the UART side of the optical isolator to ground. They're just obvious little things. All the bypass capacitors the bypass caps are taken care of on the Pico itself, so we don't have to worry about that. And there's not really a need to do bypass stuff on the SS138s. Those are going to be fine. So we just need to make sure those two bypass caps are in there. There's another thing that I noticed in doing a little bit of work off camera. And that is that if I look at the Pico setup over here, VSys should not be grounded. That needs to go away. So again, we can bodge that on the, yes, on the PC board when it comes in, and that's probably what we're going to do. So, but in the meantime, let's make sure that that's connected properly. There's something else that I want to check, because there's a wonderful little tool here that's called, that's our electrical rules checker. And I did run that, and that exposed a lot of what we're working with today. But all of these bidirectionals that are disconnected and all the no connects that are disconnected, I'm not entirely sure how to properly terminate those on KiCad to pass electrical rules. So let's do a little bit of research on that. Oh, place a no connect flag under the place menu or control Q on pins that are not connected. If I run the electrical rules checker here, I'm probably still going to have some issues. So let me run the ERC. And what's it going to tell me? I've got 6 errors and 2 warnings. So let me just go ahead and look at the errors. Input power pin not driven by output power pin. Okay, so we've got some problems. Symbol U1, pin 15, GPIO 11. Oh, it isn't connected, so I need to fix that. right. Run that again. Now I've got 5 hours. Okay, so pin 8 and pin 5, VCC and ground. Power pin not driven. And these are power pins not driven. Okay. Fun fact. Your power rails over here, ground, +5, +3 V3, they do not automatically provide power drive. So the trick to that is we have to drive those with a power output, which means that our power connector here, we're going to need to change, where'd you go? There you are. Both of these pins from being passive to being power output. Save that, close the window. Yes, I'll save it because apparently I hit the wrong button. Go back to the schematic editor. Okay, so that should take care of the power output issues. Let's run the ERC again. I'm only looking at errors. All right, bidirectional line, symbol U3, pin 11 is not connected, and U3 is this one. So why do I have an error there? Because Y7 is not connected to anything, so I do need to mark that as being not connected. And we'll go ahead and mark that as not connected. And then let's see, we run that. We've got VCC and ground are not connected, which are located where? Show me those errors, please. Okay, so this is the UART side of things, and that's its own power supply, which means that I have to make this have those two pins, pins 2 and 3, be power outputs. All right, and that should make the ERC happy, at least as far as error is concerned. But I've got a whole bunch of warnings. Pico has been modified in my MCU, symbol U1. Okay, symbol has been modified, symbol has been modified, symbol has been modified. So the fact that those symbols have been modified, those are warnings that we can ignore, which is fine. However, since this is a custom symbol, I want to fix that. So looking at some of those pins, when we're dealing with just switches, switches aren't BiDies because we're not providing an input or an output. We're simply passing stuff through. So all of these need to be marked as passive. And there are a couple other things that need to be looked at. So one of the things that I noticed is that this is backwards. I have a really hard time thinking in conventional current, but if I think about positive going to negative rather than, electron flow, then this is not going to work. It's always going to be reverse biased. So I need to fix that. That should take care of that. And then also there was that whole mess over here that we had to do that software hackery for. Sure, we can keep the software hackery, but then the software is like, why is it the way it is? We can fix it in hardware, especially if we're doing another rev. So the basic problem is that X0 through X6 need to go over here, and X0 is going to be bit 1. Let's check that again. All right, that's PA0. PA0 is pin 1, and PA0 is our column. PA0, let's see, and PA0 over here actually should be whatever, PB or something like that. I don't know. Is over here, and that is, this is our row, okay? So that's the input side. This is the column. This is the output side. That's got all of them over there. And I've got 0 tied to 16 on that one, which is not correct because that is 16 is connected to EA7. So this was not only backwards, but it was the wrong port structure. So let's get all that fixed. And I think that takes care of the errors. Now, the other thing problem I had was with the size of the resistor. The pads were too close together. Where is my thing of resistors? Or I can just grab one off of here. Horizontal pin pitch is 7.62 millimeters. Yep. Okay, that 7.62 millimeter pitch will be fine. And it's a diameter of, yep, length 6.3 millimeters, diameter 2.5 millimeters. That will be a good one, so we can change that. And let me make sure that I've got all the resistors that we have over. Where'd they go? Oh, they're on this one. So let's go to the level shifters and make sure that these resistors, I fixed that. Because the problem we had with those resistors was that they were so small that they cost us extra. I don't want it to be costing us extra. Now, with all that said, I'm going to take that mess that was the old PC board and just, I've already junked it. We're just going to go ahead and make it fresh. And Rev Double is on its way to me. So yeah, cool, nice. Okay, so I'm going to call this part complete. We got the original PC boards in. We saw all the mistakes. We got those. We worked those out, bodged it out in the software, and it worked. And the beautiful thing is, I had the opportunity to take the bodged up PC board out to an event locally and demonstrate it, and it worked just fine with, well, one caveat. There seems to be some problem with debouncing somehow. I'm not entirely sure what's going on with that, so that's going to be some debugging. But that's for later me, along with the PC boards that we just ordered. That's also for later me, and hopefully I got those right. And we'll see what happens. Okay, but at any rate, I'm really happy because that means that I do have a function. The concept works, the prototype works, and it looks like this is just going to plain work well. And the only thing that I still need to do is put together a board to adapt from the pen headers to the CoCo, or to the edge connector that is used. That's not that big of a deal. 0.5 millimeter PC board. We'll do that later. And by later, I mean like in another video. Probably the next probably the next video on this segment. So be sure to like, share, and subscribe so that you don't miss the next part of this epic journey to get USB keyboards working properly with the TRS-80 color computer. And don't tell anybody else, but there's feature creep coming.